I have two source points. One is x1, another is x2. So if there is a point, what is the intensity at this point? Then what I have to calculate, what is the distance of this point, suppose x1 from this point x and from x2 to this point. So this is the distance we have to calculate, this one and this one. That is the idea. So just in nutshell, I want to show you the way we have tried to solve this problem. Suppose we drop a pebble in a pond and wave radiates out from the top where it fell. We could create a simple representation of a sine wave to represent height. If the center of the circle is at x1, y1, that is one center is here, we represent x1, y1. And if you want to know a point P, what is this distance from this point? That is given by R1, then this distance is given by simple way like this. And what is the height of the sine wave at this particular point P? That is given by like this, xi naught sine k R1, where k is your wave vector twice pi by lambda. And then what is the similar kind of height of the sine wave due to disturbance coming from this point? That is given by this way. And what is the distance? Distance like previous one, it is given by like this way. What is the resultant effect due to the two wave at this point P? That is given by this way. So now we are already ready to simulate this effect. So I have taken a wavelength, say 5 in any arbitrary unit, separation is 5, k is twice pi by lambda, xi naught I have taken once, side of the points is 100, and separation between the points, that is two disturbing points, is 500. So spacing will be something like this, side by points. So x1, y1, x2, y2 I have defined. I have chosen all the points in my pond in a two-dimensional array. And then I have made a simple for loops for calculating heights at each and every point in my two-dimensional array, that is each and every point in my pond. After that, what I'm doing, this one that gives me the height of the water surface due to the disturbance coming from the 2 points, and for each grid points I have calculated it. So I will make a new kind of representation that is called I am show. I am show gives you the density plots of this particular kind of features. So how does it look like? So this is the kind of features that you will get after simulations. That is, if it is a pond, you have used a wavelength of 5, then dark and bright circular rings will be formed around the pond this way. And this density plots you have done with the help of plt.imshow. If you change, you can verify it by taking different separations and other kinds of things. If you make it, suppose instead of 5, if you make it 10, then there will be some changes will take place here. So this is how. So this is a kind of simulations of water wave interference in a pond, and that you can represent by density plot, and that you can do by plt.imshow. Similarly, there is another example is there, scanning tunnel microscopes. Data file has been taken from online resource, and we have extracted the data, and after that we have similarly plotted a density plot of this one. So this is a features output. It represents the surface of the this one. Or surface of the silicon. So surface of the silicon, if you what has been measured by scanning tunnel microscope, after density plot, it looks like this. That means like this. This part. So colon, I think I can stop it here. That's all about what I have to say. One feature is there, a logistic map. That is a logistic map is there, but that is not so important at this moment. This is a feature. Just I want to represent logistic map means it is a stochastic process. If you just run it and see, this is the features, disturbance kind of features. Okay, that is not so important at this moment. So I want to stop this lectures of graphics and data visualization here. If somebody has any queries at this moment, I can take one or two and you can stop it here.
Okay, please ask questions if anyone have.
And as an acknowledgement, I just want to, as an acknowledgement, I need to tell you that it is this book, Computational Physics by Mark Newman. I have been guided and I've been influenced, and most of the examples that I have shown over here, that is from this book.
Sir, can you have the PDF file of that book? Actually, yesterday I tried to get it from online, but I don't get it.
No, it is the online version is available. Selected chapters are available, and
Selected, right?
Selected chapters are available. Chapter number 2 and 7, like this. Recently, 3 is also available because I've seen selected chapters. This is a very nice book.
Thank you.
Any question anybody have?
I have one question. I'm Tamal Sarkar.
Yes, please.
Wow.
Go ahead.
Could you explain Lysage's figure? The Lysage's figure you have shown. So just how we are getting it? Multiplot.
Subplot. You have to put the subplot command.
Subplot. Yeah.
Using this subplot command, that is first argument that gives you the row number, second column number, after that figure numbers. Then you will get it. Here I incorporate. These are the simple physics and numerical calculations. After getting the results, I have to define this subplot. I will need 5 rows and 2 columns, and figure numbers are counted. Putting a counter, after that I'm getting everything.
So how you are getting this figures, different figures?
Here I have calculated y1 and y2. I have plotted plt.plot y1 and y2. Are you getting the point?
No, actually there are 6 figures. No, so each of the figure has to be first found out.
I have created a for loop.
Okay.
I have created a for loop for delta f. That is the difference of phase angle between the 2 vibrations. I have taken the delta f in phase. I have defined the phase as a range of figures from 0 to 360.
Okay. I now understood. 45 for each.
Yes. 45 angle difference.
That was the confusion then.
Okay. Anyone have any other questions? No. Okay. Okay, then if there is no question, we can conclude today's program and we'll meet tomorrow.
All right. Thank you.